Hello and good evening, and welcome to this video tutorial in which we're going to be taking a close look over a series of videos of setting up OSPF between a Juniper router, and in this case it's actually a multi-layer switch, it's a Juniper EX3200, and a Cisco router. Because one of the questions I receive a lot is what level of functionality and interoperability exists between Juniper and Cisco devices. And so this is a great way to take a look at one of the features that Juniper and Cisco both seem to coexist very peacefully with. And so let's go ahead and jump in. You can see we've got the video here. I've got two interfaces basically directly connected over to the Cisco router. The Juniper is the green router on the side here. We're going to configure some loopbacks. And in this video, we're going to bring up the adjacency, and we're going to go ahead and set up some authentication initially, and then take a look at some of the commands on the Juniper and Cisco side. And then I'm going to send a default route in to the OSPF area from the Cisco router, excuse me, and we'll see what the Juniper router reports back to us. So let's go ahead and dive in here. So I'm going to go into global config mode and say interface FA00. And we're just going to say IP address 10.1.1.1, and we'll make it a /30. I'll say no shut IP OSPF area 0. So, oh well, yeah. So I'm going to configure the process first. There we go. All right. So then we'll do the same thing for interface FA01. We're going to say IP address 10.2.2.1, and it'll be a /30 as well. We'll say no shut IP OSPF1 area 0. So now let's go ahead and set up router OSPF1, log adjacency changes, and let's go ahead and set our auto cost reference bandwidth out to 10 gigabits a second. And so we'll make that same change on the other side. So I'll say end, and actually before we do that, let's throw a host name on here real quick. All right, so we'll say end right mem. Let me save the config off. And let's go ahead and debug IP OSPF adjacency. If I can spell OSPF properly here, OSPF. And we're going to debug events as well. All right. So as you can see there, FA00 received packet from 10.2.2.1, area 0, source not on the same network. And so right now, since these are running into a switch, and it is the Juniper switch, so we're in CLI mode right now. So this quick background, so Juniper is really based on the FreeBSD operating system. So it's based on Unix, right? And right now we're at the Unix prompt. So if I type in uptime ls-lai, you can see that we are able to run a series of Unix commands. Well, we want to get into operational mode, so I'm going to type in CLI, and some people refer to it as CLI mode, but technically it's referred to as operational mode. So then I'm going to get into configuration mode or edit mode. So let's type configure, and you can see now I'm in configuration mode. So from configuration mode, I can go ahead and configure the interfaces that we want to use. And so we're simply going to use GIGI 000 and 001. So I'm going to say edit interfaces GIGI 000. And if I were to say show at this level, right? So this just shows me what the interface is currently set to. So let's go ahead and type in set unit 0, and the unit 0 just simply refers to the fact that this switch is not in a stack, right? So this is unit 0 because it's the only switch. It's not stacked together in a virtual chassis configuration where we would have additional switches. So it's unit 0, and then we're going to say family iNet because we're going to do IPv4, and then address 10.1.1.2/30. Now, if over on this side I were to say do ping 10.1.1.2 and repeat with some large number in there, let's pull the do out. So you can see that the pings are not successful, even though I've configured the internet address. So if you're wondering why, it's because when you go into edit mode or configuration mode on the Juniper side of the house, what happens is you're not editing the running config, you're editing the candidate configuration. And so the candidate configuration is, simply think of it as like a scratch area where we're able to go ahead and make all kinds of changes, and none of those changes take effect until we actually commit the configuration. So let's go ahead and do that right now. So I can simply say commit. So we get an error message telling us that when Ethernet switching family is configured on an interface, no other family type can be configured on the same interface. So let's type show. So you can see here we've got the iNet 4 family, but then we also have the Ethernet switching. Well, just like on the Cisco side of the house, right? It can't be a layer 2 and a layer 3 port. It has to be one or the other. And so in this case, we want this to be a layer 3 port. It's a multi-layer switch. It'll support that. We just need to go ahead and clean up the entry for the family Ethernet switching, right? So now let me go ahead and commit, and let's see what happens. And what we should see here is as soon as the commit wraps up, and there we go. So as soon as the commit took effect, the interface was fully configured, and now the pings are working just like they should. All right, so while we've got that going, and actually let me do a Control-Shift-6, I'll bring that to a quick stop. What we're going to do now is we're going to go ahead and configure OSPF and bring the adjacency up at least on this one link, right? And so bringing OSPF up on the Juniper side, and one last thing I forgot here, router OSPF one, as I'm thinking about it, is my router ID, which we'll just use the quad ones. Right, now you'll notice what's happening here. So we're debugging, so we're getting a lot of good, rich output. Now, this router, the Cisco router, since I've already started the OSPF process, it's actually going to elect itself as the DR. Now, by default, the election priority for Cisco is 1. And we're going to see what the default priority is here for Juniper. It's 128. And let's watch and see what happens when we get OSPF set up on this side. So what we're going to do on this side is say edit, routing options. Whoops. Actually, I got to go top. Sorry about that. So top, edit. So I go to the top level, and then I'm going to say edit routing options, so I don't have to navigate all the way through the hierarchy. And we're going to set our router ID on this side. So set router ID, and this guy's going to be 2.2.2.2. All right, so top, edit, protocols, OSPF. Now, very similar to when you configure the, and you can see over here on the right-hand side, we had that little break right here. Now, it waits for the election period, and there is no BDR out here with which it's going to compete, at least not right now. So it has elected itself as the DR. Now remember, the DR-BDR election process is not preemptive. So the fact that the priority on the Cisco router right now is 1 does not play into, does not have a role here when the Juniper router comes up with 128, which is clearly higher. It's a superior value, and if they would have come up at the same time or within the window prior to the Cisco router electing itself as the DR, then that OSPF priority would have made a difference. However, it's not going to here, and we'll see what happens. But I'll do a clear IP OSPF proc, then it'll force an election, and the Juniper will win out and become the DR, designated router. All right. So we're in the edit protocols OSPF. So all we're going to do now is say, whoops, over on the Juniper side, is set area 0 interface, and we're going to put some interfaces into area 0 here. So we'll put a loop back in there, which I'll configure in a second. We're going to say set area 0 interface gigabit Ethernet 000, and then 00. Well, actually, we'll hold off on 001. So let's go top, edit interfaces, loop back 0. I'll say set unit 0 family inet address, and we're going to make this 2.2.2.2 slash, I believe we did a 32 on the other side, so we'll make this guy 32 as well. All right, so you'll notice we haven't had any debug messages, no adjacency established yet between these two. Let's go ahead and commit our changes. So I type in commit, and let's see what kind of debug output we get on the right-hand side here. On the Cisco side, we should see some pretty verbose output here, and there we go. So neighbor negotiation done, right? We've ended up as the slave. Here's our neighbor. The database descriptors get sent back and forth. There's link state requests, link state updates, and you can see we move from what was initially the down state to the full state, right? Or to say finally from loading to full, but it was initially completely down. So now we're in the full state. So if I were to say do show IP OSPF interfaces, right? You can see here that interface fast Ethernet 01 is up, the line protocol is up, right? Broadcast type, broadcast network type. And then here you go right here. So the state is the DR and the priority is 1, because again, this is the default priority for Cisco routers. If I say run, and the reason I have to type run here is just like over on the Cisco side when I have to type do. So do show IP OSPF interfaces, because I'm in global config mode, and in specifically here I'm in the router configuration mode. So I need to type in do to have it run the command that I would run from privileged exec. And it's the same thing on the Cisco side. I'm in configuration mode, but I want it to go ahead and run a command that it would run from operational mode, and so I need to precede that command with the term run. So I'm telling it run this command, and we're going to run show, and what do we want to take a look at here? Sorry, run show OSPF neighbors, I believe. Yeah, neighbors, there we go. Show OSPF neighbors, right? So here we can see the address of the neighbor, right? And this is the actual IP address, right? If on the Cisco side I say do show IP OSPF neighbors, right? It's kind of funny how they flipped it, right? So Juniper shows the IP first, Cisco shows the router ID, right? And then the interface is second on the Juniper side, it's last on the Cisco side. The state, and Juniper just shows full, right? It doesn't show DR. We would have to dig a little deeper with, there's a detail option, I believe it is. There it is. There's a detail option which will give me more details about the neighbor, right? So here you can see it's the DR. Cisco just throws it right up here under the state, right? I don't need to add in any kind of a detail command. And it also shows me the dead time. So to get the state, right, or the DRBDR status along with the dead time, I need to use the detail command here. So you can see it tells me how long we've been adjacent, right? And I'm sorry, the adjacency time. So the dead time does show up here without the detail option, but it's the adjacency time, how long it's been up, how long we've been adjacent, so 3 minutes. And you can see the dead timer counts down, right, just like it does over on this side, 32, 31, and then back up to 39. Well, we missed 39 and shot up to 38, or dropped down to 38. So again, you can see much of the same information that you see on the Juniper side of the house. So what we're going to do now is we've got the loopback configured. Let's take a look at the routes that we've got. So if I were to say run show route. All right, so we've got the directly connected route here, and here's the 10.2.2.0, which we're learning from OSPF, right? So over on this side, if I were to say do show run interface fast Ethernet 01, you can see that this is the 10.2.2.0 network, and it's being advertised into OSPF. If I say do show run interface loopback 0, did we configure it? Okay, we haven't configured it yet, so let's go ahead and say interface loopback 0, IP address 1.1.1.1, and let's see what we got there. And 255 IP OSPF 1 area 0. So you can see it's going to add that interface to OSPF. Now when I type run show route, so we're originating that route, which is our loopback address, and there it is. So if I were to say run ping 1.1.1.1, we don't have any issues at all, right? So we've got connectivity. How about over here? Do ping 2.2.2.2, right? Works like a champ. Do show IP route. And we are definitely learning that route via OSPF. All right, so let me kill this here, and let's bring the route table back up again. So let's take a look at the route table and some of the things that we see in the route table. So we can see that the route has been learned via OSPF. Same thing over here, right? Cisco just shows an O. And then we've got the administrative distance for OSPF, which is 110. And then we have the metric, right? The cost of 100. We have much the same output over here. Here we've got the metric is listed out here as 2. So now why are these metrics so off, do you think? Well, remember on this side, on the Cisco side, do show run section OSPF, we set the auto cost reference bandwidth to be 10 gigabits, right? So on a 100 meg interface where it should be 1, right? The cost should be 1 because that's the default auto cost reference bandwidth value. When we set it out to 10 gigabits, it went from 1 to 10. It would have been 10 at a gig to 100. So we've set it on this side and it sees it as 100. However, over on this side, you can see that the metric is, at least to the loopback anyway, is 2. And where are we at here? And then it shows the metric as 101 over here out the gig 00 interface. But we never set the auto cost reference bandwidth on the Juniper side. So let's go ahead and do that. So I'm going to say top edit protocols OSPF. And what options do we have here? So we'll do set, trim them down a little bit. Set, and it's reference bandwidth, right? Now, this is interesting. It says reference bandwidth. This is bandwidth for calculating metric defaults. Well, if I put in 10,000 and I type show, take a look at what it sets it to. So over on the Cisco side, when we make that configuration change, so if I say router OSPF 1, auto cost reference bandwidth question mark, the value is entered in terms of megabits per second. So when I type in 10,000, that's 10 gigabits a second. However, over here, it's in bits per second because you can see I type 10,000 and it says 10,000K. Well, we don't want it to be 10,000 kilobits, right? We want it to be 10 gigabits. So now when I type show, it says reference bandwidth 10G. So let's go ahead and commit this, and let's see if this has any effect on the cost of any of the links which we looked at previously. So run show route. Aha! So there you have it. So we were receiving inconsistent values, right? Because on one side we had it set to 10,000, well, I should say 10 gigabits a second. And on the Juniper side, it wasn't set at all. So we went ahead and set it. So now things look a little better. So let's take a look at the routing table here on the IP route on the Cisco side. And what do we see? Well, we see that it's still 100 on the Cisco side, in part, right, because of the fact that we had gig interfaces initially. Now we've changed the auto cost reference bandwidth, so we're still fast Ethernet interfaces on the Cisco side, right? These are FE interfaces on the Cisco side, and gigabit Ethernet interfaces on the Juniper side. However, you can see that it's still, the values are not the same. So for me to get to the loopback, it's 100, but for me to get to the loopback of the Cisco router from the Juniper router, it's 101. And the reason for that is the Cisco counts the hop to the loopback as 1. So if I were to say do show IP interface loopback 0, or I'm sorry, do show IP OSPF interface loopback 0, right? What's my cost? Well, my cost is 1. So it's costing me 100, like it should, because now the auto cost reference bandwidths are matched up. So it's costing me 100 to get to the router, and then Cisco charges 1, right? Or there's a value of 1 to get to the loopback address. On the Juniper side, that's not the case. So do show IP route. You can see here that the cost is 100. So let's take a look at the run show OSPF neighbor. Right, so you can see the state is full. If I do neighbor detail, which is really what I wanted, you can see that the DR is the Cisco router, the BDR is the Juniper router. Well, let's change that, right? Because remember, the priority of the Cisco router by default is 1. Do show IP OSPF neighbor. What does the Cisco router show? The priority of the Juniper router is 128. So let's say do clear IP OSPF proc. And again, we're debugging, so we're going to see all this in real time. You can see the election process takes place. Database descriptors, link state requests, and updates are sent back and forth. We have a neighbor change event that takes place. We have an election between the DR and the BDR. And the Juniper router wins out, as it should, because do show IP OSPF interface, or I'm sorry, not interface, neighbor. Its priority is higher. It's 128. So let's rerun this command on the Juniper side and see what we've got. And as we would expect, the DR has now been changed to the Juniper router. The BDR is the Cisco router, because again, Cisco router had a priority of 1. Let's go ahead and take a look at the database. So on the Juniper side, it's run show OSPF database. Oops, keep typing that wrong. OSPF database. And so here's what the Juniper side sees, right? So we've got the type 1 LSAs, which are the router LSAs, and we've got the type 2 LSA that's being generated by the DR, right? And that's why it's the advertising router, right? 2222 is the router ID for the Juniper router. So it is the originator, and it will flood out the type 2 LSAs. Each router will send out its own type 1 LSA. So let's take a look at the database over here. Do show IP OSPF database. And we've got much the same. We have 2 type 1 LSAs, right? So here are your router LSAs, and then we've got the single network LSA, which is being flooded out right now, which represents the Juniper router, right? All right, so that's pretty much a straightforward setup for OSPF between a Cisco and a Juniper router. And as you can see, they're coexisting without any issues at all. So the final thing we're going to do is let's set up authentication between the two routers. So I'll do the authentication piece on the Juniper side first. And so we're going to say top edit protocols, OSPF area 0, right? So if we do a question mark here, actually I should do set. So I'll do set, and what we're going to do here is we're going to go ahead and set the authentication type, and we're going to set up authentication between this. The authentication type is going to be type, or we're going to use MD5, right? Because the Cisco router can do MD5 as well. So I'm going to say set interface gigi 000 authentication MD5 1 key, and we'll just make the key CCIE, right? So I'm going to go ahead and commit this change right now. we should definitely see something happen over on, and there you go. So on the Cisco side, so as soon as I set authentication up, take a look at what happened. Receive packet from 10112, mismatch authentication type, input packet specified type 2, we use type 0. So type 0 means no authentication at all. And remember, there were 3 types of authentication with OSPF. You've got null authentication, which is this type 0, it's no authentication. You've got type 1, which is simple authentication, plain text password. And you've got type 2, which is using the MD5 hash. So if I were to say do show IP OSPF neighbor, we can also witness, take a look at the hold time, and we should get it down. We were at 1 second there. And then, so you can see here, we caught it, the dead timer with a second to go. The adjacency then went down, right? It went 3 times the hello time, which is, or I'm sorry, 4 times the hello time, which was 40 seconds. It dropped it all the way down to 0. So the adjacency is now went from full to down. So if I were to say do show IP OSPF neighbor, right? We have no neighbors at this point. Do show IP OSPF route, right? So it shows us some routes. However, we can't get to any of the routes on the other side, right? It's not showing us the routes that are on the other side. If I say do show IP route, those routes have all been withdrawn from the routing table. All of the routes over to the Juniper side have been withdrawn from the routing table. So let's go ahead and sort this out. Let's say area 0, authentication, message digest, and then let's jump into interface FA00, where we will go ahead and say, and let me go ahead and say do you all. Let me kill the debugging here for a second because it's driving me crazy. So now let's go ahead. We've declared that we've got the that we're going to use message digest authentication on the Cisco side. And now let's go ahead and set this up here. So I'm going to say area 0, actually in the right interface. So IP OSPF and message digest. There it is, message digest key. So IP OSPF message digest key. We're going to match the key ID with the 1, MD5, and we're going to say unencrypted password CCIE. And let's see if we've gotten, wow, that was quick, right? So we went ahead and set it, and then as you can see, it immediately brought the adjacency back up. So if I were to say do show IP OSPF neighbor, right? Our neighbor relationship is back. Do show IP route, right? I'm picking back up the routes that are being redistributed. And let's take a look on the Juniper side. So if I were to say run show OSPF neighbor, you can see the neighbor relationship is back. What about neighbor detail? And as you would expect, the adjacency has only been there for 41 seconds. Now, if I type run show route, right, you'll notice that the transit network, which is directly connected, that those are not in the routing table as OSPF routes. And the reason for that is that there's a better route. There's a route with a better administrative distance, and that's the directly connected route right here, right? So this will go in as a directly connected route, just like it does over here on the Cisco side, right? Because again, the administrative distance is 0 for the directly connected route. All right, so we're going to go ahead and stop here. The next part of this video tutorial is going to take a look at not only setting up IPv6 OSPF between the two routers, but we're going to set up some of the other features within OSPF, and specifically on the Juniper side, we're going to set up the equal cost multipathing, right? Because by default, the Juniper router does not do equal cost multipathing by default. In fact, let me edit interfaces. Let's bring that other interface into the fold, GE-001, and let me say, you know, delete. We'll pull out the unit 0 family Ethernet switching, and we'll say set unit 0 family inet address, whoops, 10.2.2.2/30, and let me say yeah, run show configure. And let me come down here. I just real quickly want to see, did I put in protocols OSPF? I did not. So let's set that as well. So top edit protocols OSPF, and we're going to say set OSPF. Whoops. Actually, it's set interface. Set interface. I'm drawing a total blank right now. Set. What did I run? Or set OSPF. Set area. Set area. Sorry about that. Set area 0. Interface GE001. So we're going to commit that. And on the Cisco side, if I say do show run interface fast Ethernet 01, what do we have? So that guy's all ready to go. So do ping 10.2.2.2. Do we get any response back? All right, so we've got connectivity. We should also see something telling us that it is going to form an adjacency on that link as well. So let's see, do show IP route. Yeah, we should see something telling us that it's going to form an adjacency on that side as well. Let me commit complete. The interface is in there, and it's in OSPF. So we've got, no, okay, it did drop it in there. And you can see we're doing the authentication per interface, because there is no interface here on Gigi 001. So let me do, and that can't be, yeah, okay. It just dawned on me. So on the Cisco side, so do show run section OSPF is I've set up authentication for area 0. So that's not going to come up until I configure the Juniper side as well. So let's say top edit protocols OSPF. I think we're already in there, but that's okay. So let's go ahead and say set interface Gigi 001. Oops, sorry. Set interface. It doesn't like that. Hold on. Where are we at? Top edit protocol. Oh, OSPF area for the area. There we go. All right, so let me go ahead and get this added in now. So we're going to say set interface GE001 authentication MD5 1 key is CCIE. All right, so I'll commit that. And I completely forgot I'd set it up for the entire area 0. So we're going to see something over here shortly that's going to tell us that we've got the adjacency established. If I type show, you can see that we have authentication set up on Gigi 001. Let's make sure we have it on interface FA01 here. So just IP OSPF message digest key 1MD5 CCIE. And we should see some activity here shortly. Okay, there we go. All right, so it went from loading to full. So now we have do show IP route. We should have 2 equal cost paths to go from the Cisco router over to the loopback address on the Juniper router. And what do we see on the Juniper router? Run show route. So to get to the loopback address on the Cisco routers, you'll notice we have 2 paths. However, the greater than sign is indicating that only this path has been selected, right? So if I were to say on the Cisco side, do show IPsef 2.2.2.2/32, you can see that in the fib, right, the forwarding information base, the fib is reporting that it has 2 equal cost paths, and so Ceph, Cisco Express Forwarding, is going to load share across those by default. On the Juniper side, that is not the case. So if I were to say run show forwarding, I don't think it's forwarding options. That's not it. Forwarding run show, I think it's forwarding table. forwarding options, firewall, event options. Yeah, I'm trying to remember the option to see the fib on the Juniper side. It's run show. Give me a second here. Run show. Could have swore it was run show forwarding. Run show, is it route? Run show route. Forwarding. Forwarding, there it is. Run show route forwarding table. Run show route forwarding table. So when I type run show route forwarding table, you can see that in what is the equivalent of the fib, right, on the Juniper side, the forwarding table, it has only installed a single route across which it's going to forward, right? So it's a unicast route out GigE 001, which is what we saw when we looked here, right? What path did it choose? The path out GigE 001. So again, by default, Juniper doesn't do equal cost multipathing, and so this is also something we're going to be setting up in the next video in addition to IPv6. And a quick note, IPv6 does by default do the equal cost multipathing with Juniper. But for the IPv4, we're going to go ahead and set up equal cost multipathing so that it will select either of the links on a per flow basis, not a per packet basis, on a per flow basis. All right, well, thank you for watching sort of this basic setup of OSPF between Juniper and Cisco routers. Again, the next video is going to continue to build on this. We're going to take a look at equal cost multipathing on the Juniper side, and we're also going to pull in IPv6, which is OSPFv2, and we're going to set that up between the two routers. All right, have a great evening.